So welcome to today's chemistry tutorial content. Today we're going to look at precipitation reaction, otherwise known as double decomposition reaction. So this class is meant for those in senior secondary 2 and senior secondary 3, and also for those in their first years in university who are not all that good in chemistry. So if you are not subscribed to the channel, go to the channel, under the channel, the best science brand of the channel name, you see a small bell, a tiny bell, by the side of it is written subscription. Just tap on the bell and get subscribed immediately, so you can be seeing our videos as we post them from time to time. Now we'll go back to our work for today, which is precipitation reaction. I remember in our previous lecture, we already discussed what is meant by displacement reaction. So today we are looking at precipitation or double decomposition reaction. So what is precipitation reaction? We say that precipitation reaction is a reaction between two soluble compounds to produce a soluble and an insoluble compound. So two soluble compounds to produce a soluble and an insoluble compound. For instance, you have a compound AS in aqueous state. Aqueous means soluble. React with compound BT also in aqueous state. When they combine, we can split the AS into A positive cation, S negative anion. Split compound BT into B cation and T negative anion. A changing unlike terms, A goes to T, whereas B goes to S. We now produce AT and then BS. Out of these two product form, one of them is aqueous, while the other one is going to be solid. So two soluble compounds giving us one soluble and one insoluble. The insoluble compound formed during precipitation reaction is called the precipitate. I come again. The insoluble compound formed when you mix two soluble compounds is called the precipitate. And in chemistry, we abbreviate it with PPT. So the precipitate is the insoluble product formed when two soluble compounds or two aqueous solutions are mixed. So that is the term precipitate, meaning a compound formed when two aqueous solutions are mixed together. So on the board is an example of precipitation reaction between silver triosonitrate and sodium chloride. You can see this is soluble, this is a soluble compound, this is an insoluble compound. This is the precipitate or PPT, while this is a soluble compound. If you look at the analysis, this splits into silver ion, cation, and triose 5 ion, while this split into sodium ion and then chloride ion. When you move unlike terms together, you then produce silver chloride, which is an insoluble compound, then produce also sodium nitrate, which is a soluble compound. The question is this: we can see how a present reaction whereby you have perhaps you have this compound, a soluble compound, plus also another soluble compound, an acid which is also soluble, giving us Na with split ions. The acid splits into either ion, and then the sulfate ion. You marry all their terms together, you produce HNO3 and then Na2SO4, aqueous, and this could be volatile or gaseous. So that is also a kind of double decomposition reaction. So having done that, question is this: how do we know whether a compound is soluble or not? Because most cases we don't know when to put solid, we don't know when to put aqueous. How do we know whether a compound is soluble or not? There are some rules guiding the solubility of salts, which we're going to outline here on the board. There are some rules guiding the solubility of salts which we're going to outline. So we now have the guidelines to solubility of salts. We should know number 1, all common salts of sodium, potassium, and ammonium are soluble in water. All common salts of sodium, potassium, and ammonium dissolve in water. That is why when we see a salt of sodium in chemical reaction, for instance this, we normally put aqueous, showing that it's soluble in water. Another example, sodium carbonate, we put aqueous in a chemical reaction. Potassium nitrate, we put aqueous. Ammonium compounds or salts, we put aqueous, because we can see the cation sodium, potassium, and ammonium present in these salts. We say they are soluble in water. Number 2 rule, we say all triosonitrate salts. All triosonitrate salts are soluble in water. So any salt bearing this radical NO3 is soluble in water. For example, you can have NaNO3. This salt is classified as being soluble because of the presence of either sodium, since we have made the point in number 1, or presence of NO3. Or another example is this. This salt is soluble in water. We may not know anything about copper salts for now, but because of NO3, this salt is soluble in water. Lead nitrate. You may not know anything about lead salts, but because of the presence of NO3, this salt is a soluble salt. Then rule number 3, all hydrogen triose salts are soluble in water. All hydrogen carbonate salts dissolve in water. For instance, sodium hydrogen carbonate is classified as a soluble salt because of the presence of sodium based on rule number 1, or because of the presence of hydrogen carbonate in a soluble salt. Calcium hydrogen carbonate is classified as a soluble salt because of the HCO3 that is present. So that would be a kind of guideline for us to know soluble salts and insoluble salts. We still move on. We'll go to the 4th rule. So the first rule has said that all common salts of sodium, potassium, and ammonium are soluble in water. I have examples here. Number 2 rule will say that all triosonitrate salts are soluble in water. Those examples: NaNO3, CuNO3, and then PB bracket NO3 2. They are carrying nitrates in them. The third rule, all hydrogen carbonate salts are soluble in water. We have examples, sodium hydrogen carbonate and calcium hydrogen triazocarbonate. Because they are carrying the hydrogen carbonate ion, they are soluble in water. We go to the fourth rule. We can have, says, all tetraozo sulfur salts. That is, any salts carrying the ion SO4 are soluble in water. Except, we have exemptions here, except calcium 3/6, barium 3/6, and lead 2 3/6. So these salts are soluble in water. All SO4 salts are soluble in water, except this. So any salt, like example, what we say sodium sulfate is in the water, copper sulfate is in the water, potassium sulfate is in the water, magnesium sulfate is in the water. So this salt is soluble in water because of the fact it contains sodium, since all common salts are sodium, or because it contains SO4. This salt is in water. We may not know anything about copper because of SO4 is stable salt. This salt is soluble in water because of potassium. All common salts of potassium are in water, or because of the SO4 anion. This salt is soluble in water because of SO4. You may not know anything about magnesium salt, but because of it has SO4, it's a soluble salt. So, but these ones are the exemptions. These ones are not soluble in water. But in chemistry, we know that calcium 3/6, calcium sulfate, we say is sparingly. This one, among the insoluble salt, this one is sparingly soluble in water. What it means is that this salt dissolves slightly in water, little amount of it can dissolve in water. So we say it's sparingly soluble in water. Then rule number 5, we say all chlorides are soluble in water. Salts containing chlorine in them are soluble in water. There are also exemptions, except lead chloride, lead 2 chloride, silver chloride, copper 1 chloride, and mercury chlorides, mercury 1 chloride. So all chlorides are soluble except these ones. These ones are the insoluble chlorides. But you should know that lead 2 chloride, PbCl2, dissolves in hot boiling water and reappears on cooling. So this salt, even though it's soluble in ordinary water, but in hot water it will dissolve and reappear, come back again on cooling. So let's take a look at what we have written above. The sixth rule, we are seeing sulfurs, we are seeing nitrates, I think, many carbonates. All triazocarbonate 4 salts. Any salt carrying CO3 ion are insoluble in water. All carbonate salts are insoluble in water except those of sodium carbonate, potassium carbonate, and ammonium carbonate. All carbonates are soluble in water except these 3. As we said before, sodium salts, potassium salts, and ammonium salts are soluble in water. So every other carbonate is insoluble in water. So if you look at, when you have an equation like this as a student, where this is given to you, and then you have this. So you should be able to know the solubility of salt. The solubility rule, when you have R pure written here, that is based on the rule number 2 that we have written earlier on, that all trials and clarified salts are soluble in water. That will have R pures here. Then this one will have R pures, reason because all potassium salts are soluble in water. That's the reason. This one will have also aqueous. Reason, all potassium salts are soluble in water, or all nitrates are soluble in water. The reason why it's aqueous. This one will have solid. Why? Because all chlorides are soluble except, as I said before, silver chloride, lead chloride, copper 1 chloride, and mercury 1 chloride. So these ones are not soluble in water. So that's why we wrote solid here. Or perhaps you have barium chloride, an equation of this nature, plus maybe H2SO4 given to you, aqueous, giving us BaSO4, and then 2HCl, maybe gaseous. So why do we have all these statements here? This is soluble because all chlorides are soluble in water except silver. This is not silver. Lead 2, this is not lead. Copper 1 or mercury, this is not copper, this is barium. So this is a soluble salt. Acids are soluble in water. This is an acid. Then this one is solid, not aqueous. Solid. I told you that all sulfates are soluble in water except lead sulfate, barium sulfate, calcium sulfate. So this is among the insoluble sulfate. That's why you have solid here. There is an acid, which will be aqueous or volatile gaseous. So these are examples of double decomposition reactions. So you can see it's an interesting class showing us substances that are soluble and the ones that are not soluble. In double decomposition, normally involve a change of acid radical. If you look at this, we have barium and then chloride. If you break them into ions, hydrogen and SO4. These two are called acid radicals because when you combine them with hydrogen, you get acid. Combine it with hydrogen, you get HCl. Combine it with acid, hydrogen, you get H2SO4. So it involves a change of acid radicals. When you change, you have valency cancel, you have this. When you bring this one together, you have that. So we can say it involves a change of acid radicals, and this reaction is normally used to produce insoluble salt in the laboratory. It's one of the key methods of preparing insoluble salts in the laboratory. So by using double decomposition, by using precipitation reaction. So now we're going to look at practicals, the practical aspect. We're going to do some simple practical to demonstrate this reaction. So as you can see on the board, we have another reaction that involves precipitation or double decomposition. Silver nitrate, by virtue of being a nitrate, is a soluble salt. Sodium chloride, by virtue of having sodium inside it, is a soluble salt. We go to the product. Silver chloride is among the insoluble chlorides, so it's a precipitate, it's white in color. Then sodium nitrate or sodium 5, or common salt of sodium, or because it's a nitrate, it should be a soluble salt. So we're going to demonstrate this reaction practically. We can see what happened here. Okay, looking at this, we now have do the practical. This is our sodium chloride solution, aqueous. Look at this, it's very clear, nothing in it, but except the salt is up inside it, and water. This is silver nitrate, somehow cloudy in appearance. So if we mix them together, we expect to have silver chloride produced. So let's need, that is a white precipitate formed. Immediately together, let's verify the experiment. You see, we have a white precipitate, white solid formed inside it. That white solid is the silver chloride. You can see some liquid under, that's the sodium triiodonitrate 5 inside it. So that is it. So the question is this, are all precipitate white? No. we still have colored precipitate. We're going to use an example which involve a colored precipitate. Okay, so I'm going to join you soon. So on the board, we have a reaction between barium chloride and sodium carbonate. So we split the barium chloride into its components. Barium have valency of 2, take the 2 back. Chloride have valency of 1, chlorine. Sodium have valency of 1, then carbonate take back valency as 2 minus. Then you exchange on like charges. You have equal valency, 2 cancels, you bring them together. Then sodium goes with chlorine, you have it there. So all chlorides are soluble salt, so you put aqueous here. All chlorides are soluble salt here, except, as I say, silver chloride, lead chloride, copper 1 and maybe 1. So this is soluble chloride. Then all sodium salts are soluble. Then going to this side, sodium salts are soluble. Have sodium, they are soluble. This sodium. Then this one, all carbonates are insoluble. This reaction, we now have these two test tubes. One of them, this one on my right hand side is barium chloride. On my left hand side, barium chloride. While this one on my right hand side is sodium carbonate, dissolved in water. They have a solution. It appears that you can see nothing, as if nothing is inside them. So when we mix them together, we expect to have barium carbonate, which is a white precipitate. So here we are going to mix them together now and see whether, of course, whether what we have there is actually going to happen. So I'll mix the two of them together. So we can see a white precipitate form. So this white solid is barium carbonate produced here. So this is an interesting aspect of chemistry. So this white solid form here is called a precipitate or a PPT. So this white substance represents barium carbonate, while the remaining solution underneath the liquid there represents sodium chloride. So we have this reaction on the board between copper sulfate and aqueous sodium hydroxide, giving us copper 2 hydroxide, which is a pale blue precipitate solid, and then sodium sulfate, which is aqueous. So let's demonstrate this reaction. So the blue solution represents copper sulfate, while the colored solution represents sodium hydroxide. So we're going to mix them together and see we're going to have a pale blue precipitate formed inside. So we have a blue precipitate formed inside the container. You can see this side of the blue. It's a pale blue PPT. This side of the test tube formed inside. That represents copper 2 hydroxide produced. So we see that it is not all precipitate that are colored, that are white. Some are white, some are blue, some are green, depending on the ion they present. If the precipitate has a blue color, indicates copper. If the precipitate has a green color, indicates ion 2. If it has a reddish brown color, it will indicate ion 3, and so on. So having done that, then we'll look at the idea or the word called precipitating agent. Precipitating agent. We may have this reaction AB aqueous plus SY aqueous, giving us perhaps AY plus BAY plus SB. Perhaps this is the PPT or the precipitate formed. So the precipitating agent should be one of the reactants. So out of these two, which of them is the precipitating agent? Then look at out of these two, the president agent is going to be AB. This is our PPT agent. So why is this one called the president agent? Then look at the president agent, then look at the precipitate. You see that this agent donated is anion. The anion is the negative ion, B minus, to the precipitate. So the reactant or the reagent that donates is anion or negative ion to the precipitate is called the precipitating agent. Like in this case now, the precipitate is copper hydroxide. The precipitate agent is sodium hydroxide. This is the PPT agent because the hydroxide ion, which is negatively charged from this reagent, is found in the precipitate. So the precipitate agent remains the substance which donates its negative ion or its anion to the precipitate. Another example is if I should use this reaction. Perhaps we have sodium sulfate plus barium chloride, giving us barium sulfate solid plus sodium chloride, aqueous. By being solid or insoluble, this is called the precipitate. Then these two reagents or reactants, which of them is the precipitate agent? Look, if you examine the reactant and the precipitate, this is the PPT agent because it donates its negative ion, which is SO4, is found in the precipitate. So having done that, we have come to the end of this lecture, which involves double decomposition reaction or precipitation reaction. Always stay connected to the YouTube channel. If you are not subscribed to the channel, please, or you come across the channel as a random YouTube searcher, you try to subscribe on the channel. We are on the summer holiday. We are creating so much content on practical chemistry, practical physics, mathematics, and further mathematics. You subscribe if you're in SS class, SS1, SS2, SS3, even you're in year 1 of higher institution, you subscribe to the channel. How do you subscribe? Go to the channel's name, you see Best Science Brain, then under it, you see a small pear-shaped bell, and then you tap on the bell only once, and you get subscribed. So the subscription has no disadvantage. It does not take away your data. All it does for you is whenever we post a video, you'll be among the first people to see our videos. And whenever we announce we're going to give a handouts or takeaway, you can be among those that benefit from the handout. Thank you very much for listening.